Okay, this is just about comparing the delta G, GF, yeah. For H2O is negative 237, but delta GF H2O is negative 228.6. So many gases and liquids have standard free energy change values that are negative, but many others have positive. Yeah, this is just information for all of you. Okay, now we want to find the Gibbs free energy reaction. Reactants will change to the product, and we can find the Hasse cycle for this reactions will be like this. Okay, this is the relation between delta GF of the, let's say, the first element to form the reactants and elements to form the products. So we have two delta GF formation at two delta GF and one delta G. We can find the delta G reactions through these relationships. Okay, so the delta G reactions is equals to delta G product minus delta G of reactants. So once again, this is same as the entropy change of formation of reaction and enthalpy change of reaction. Always product minus reactants. Okay, once again, its substance has its own delta GF value for the pure elements such as carbon, calcium, bromide, helium. The delta GF is 0. So this is like enthalpy change, yeah. Calculate the delta G reactions for this. So we have product L2O3, we have reactant Fe2O3. So product minus reactant. Okay. So what's the value of delta G? Okay, negative 840. Yeah, this is spontaneous. Okay, now let's see this question. Draw Gibbs free energy cycle to calculate the standard free energy change of decomposition of sodium hydrogen carbonate. So actually, we no need to draw the cycle to find the Gibbs free energy, since we can use this data directly. Product minus reactant. So we have product this, and this. Okay, just add these three together and then minus this. Don't forget to multiply by 2. Yeah, since it has 2 coefficients. The result is positive 25.9. So delta G positive, that means not spontaneous. But if we still need to draw the cycle, how to do this? Okay, this is the delta G reaction. And we have the delta GF formation from element to form the product. Yeah, the product in this case could be the reactant, could be the Na2CO3. The reactant, that means NaSO3. So we need to use 2 Na, 2 C, 3 O2, and 1 H2. Okay, this is 2 times enthalpy GF of NaHCO3. Okay, and this we want to form Na2CO3 from Na, C, and then O2. We also need to form CO2 from C and O2. We need also to form H2O from H2 and O2. So actually this arrow shows us about 3 delta GF. Okay. Okay, so you can find that delta G ration actually this, right? So that's why you add all the delta GF of Na2CO3, CO2, and H2O, and then minus 2 times delta GF of NaSCO3. So once again, you can draw the cycle to find the Gibbs free energy ration, or you can also use the formula, the sum of delta GF of products minus the sum of delta GF of reactant. Okay, you can choose which way is much more easy for you. Yeah. Okay, this is same. Okay, product minus reactant. Okay, so we already discussed all about system, and system. Now we'd like to see about the delta G ration. Actually, the delta G ration is equals as delta H ration minus the delta S rations. This is exactly same as the delta G system, but you just need to change the word system to reaction. Okay, so once again, delta G equals to delta H minus T delta S. And now I have this question. Okay, calculate the delta G ratios at 298 Kelvin for the thermal decomposition of calcium carbonate from the following data. So how to do this? Calcium carbonate decompose to form calcium oxide with CO2 gas. The coefficient is 111. Okay, first we should find the delta S ration by using application of product. This is CaO plus CO2 minus CaCO3. Same way to find the delta S ration, product minus reactant. The value is so delta G ration delta H minus T delta S again joules 2 kilojoules. So positive 130 kilojoules per mole. Okay, positive value, not spontaneous.